Alright guys, so in this video we'll talk about a very important concept in chemistry. Well, it is a subtopic under a main topic in chemistry. This is called relative molecular mass. So the abbreviation for this is RMM. And just to mention something very significant, whenever you see RMM, firstly, know it means relative molecular mass. But if you don't see RMM, I want you to understand that RMM, which is relative molecular mass, and molar mass, and atomic mass, they are all the same thing. I repeat, RMM, molar mass, and atomic mass, you may want to write that down, they are all the same thing. So if I ask you, what is the mass number of, let's say, sodium, for instance? So I can also rephrase and ask you, what is the RMM of sodium, or what is the atomic mass of sodium? So know that all these three can be used interchangeably and they mean the same thing. But that's not our focus for this particular video. For this particular video, I want to show you how you can calculate relative molecular mass. So we're going to talk about the calculation because it's a very important aspect in chemistry. In several external exams, you will need to learn how to calculate them, and that is what we'll be talking about in this particular lecture. Let me just give you a very quick preamble, really quick. So to calculate the relative molecular mass of a compound, we need to write out the mass numbers of each element present in the compound. So let's start with this. The very first one we'll talk about is limestone. That is calcium trioxocarbonate 4, that is the atomic number. Then limestone is the common name. So calcium trioxocarbonate 4 is the IUPAC name. Then limestone is the common name. So it is essential that you know this dichotomy. Now let's go into how we can calculate this. The first thing to do is to bring out the mass numbers of each of the component elements. For instance, the mass number of calcium, just a moment, the mass number of calcium will be brought out, the mass number of carbon will be brought out, and the mass number of oxygen will be brought out. So we have 1, 2, 3 elements here, and to do that, bring in the mass number of calcium. Calcium has a mass number of 40, so bring that out. Then carbon has a mass number of 12. Then oxygen has a mass number of 16. And remember, there is a 3 here. We're going to multiply that 3 by 16. And just to mention, if you see a 3 outside, okay, it can be any number. It can be 2. It can be whatever it is. So this 3 as a case study, if it is outside and it is attached to just one element, then it will affect only that element, except and unless there is a bracket. But in this case, we don't have any bracket here, so it means these 3 affect only oxygen. Now, let me give you an instance. For instance, look at this. This is calcium nitrate, for instance. We have a 3 here, then we have a 2 outside. This 3 you see, we affect only oxygen. Then this 2 will affect everything in the brackets. You get it now? So we'll talk about this in our next one. So just to make sure you understand that. So let's get back to number 1. Now, after bringing all this out, the next thing to do is to plus them. We're going to sum them up. That is the very next thing. But according to BODMAS, we need to multiply first before we add. By so doing, we just have to bring down this 40 plus 12, then 16 times 3 will give you 48. It is very easy. If you're unsure of that, the way to do it without a calculator is to do 15 times 3 first. That gives you 45. Then you have 1 each from the leftover. So 1 times 3 will give you 3. If you add 3 to 45, you get 48. Now the next thing to do is to continue. So this is just simple mathematics. 40 plus 48 will give you 88. Then 88 plus 12 will give you 100 grams. So this is the relative molecular mass of calcium trioxocarbonate 4. Now, number 2, let's talk about calcium nitrate. This one. Now, the first thing to do is to bring out the mass numbers. Here we have 3 elements. Calcium is one of them. Then we have nitrogen. Then of course we have oxygen. Now, after doing that, we'll bring out the mass numbers. For instance, the mass number of calcium, like we did before, is 40. The mass number of nitrogen is 14. The mass number of oxygen is 16. Now we have a 3 here. So this 3 will affect only oxygen. 16 times 3. Then we have a 2 here, which will affect everything in the bracket only, because the 2 is outside of the bracket, so it will affect only the bracket. Now, so of course we're adding them up. 40 plus 14 plus 16 times 3, then we have a 2 outside, and for that reason I'm just going to put this values in bracket because of the 2 outside. No, we still haven't used the 2 yet. So of course, what's my 40? Bring it down here. And of course, from both mass we have to multiply first before adding. So by so doing, I simply have to do 2 times 14. That gives me 28 plus 16 times 3, of course, is 48. Then 48 times 2, you see that now, gives me 96. See? So if you do that, the next thing to do is simply to multiply everything, and when you add that, you should get 96 plus 40. Now, most of you have issues when it comes to calculation. Well, the fastest way to do it is to just use a calculator to save yourself the stress and the time. But I don't like using calculator for easy stuff like this. I just use my brain to get the answer. So if I want to do this, it's pretty easy. I will assume 100 plus 40, that gives me 140. You see that now? 140 minus the 4 that I added from here, minus 4, that gives me 136. Now 136 plus those 28 you have here, that will give you what now? 136 plus 28. That may be challenging, but I can say 136 plus 30, that will give me 166. Then I'm going to remove the 2 that I added before. That will give me minus 2. That will be 164. So the answer is 164. So everything here gives me 164. Therefore, I can say that 40 plus 14 plus 28 plus 96 gives me 164 grams. But that was a long process. If you don't want to do that, you can simply use a calculator. All right, that is it. Now let's look at the last question under this, very important. So let me give you, let's do lead 2 trioxonitrate. That's PbNO3 bracket 2. Now the mass number of lead. Now it is imperative that you know mass numbers of elements, because if you don't know the mass numbers of elements, you won't be able to get them correctly. So know mass numbers, extremely important. For example, the mass number of lead is 207. Then of course you know the mass number of nitrogen, that's 14. Of course oxygen, that is 16. So you know what I'm doing? Of course I have a 3 here, and that 3 will be here times 3, of course, like I did before. Then of course I'm adding everything together, and the 2 I have here, we affect only the stuff in brackets. So basically going to put this in bracket now, so I can multiply all by 2, just the bracket values, not everything. So I have 207 still plus 2 times 14, that gives me 28. Of course, 16 times 3, that gives us 48. 48 times 2, that gives us 96. So if you have this up with a calculator, you should get 331 grams. That is a relative molecular mass of this. So what will happen is I'll call this video a part 1, because I need to solve more questions, like 2 or 3 more, and then in the part 2 of this video I will solve more questions.